Section 15 is on something called the chain rule, and we're going to learn this today, and we're going to use it every single day for the rest of the year. So there have been times when people have been absent. I should probably take attendance, by the way. So people have been absent, and they've missed this section, and they've struggled in calculus for the rest of the year because they didn't watch the video and they didn't figure it out. All right, you all are here today. You're paying attention. You're going to understand this. It's not that hard of a concept, okay? So it says, based on our current knowledge of derivatives, how would you find the derivative of y equals 3x minus 4 quantities squared? So if you have this, right now what we would do is we would FOIL out our 3x minus 4 times 3x minus 4. We would rewrite it as 9x squared minus 24x plus 16. Right, when we FOIL it out, our outer and inner combine to be negative 24x. And then we would quickly take the derivative, and we'd be like, okay, 18x minus 24. Done. And that was perfect for things like that, where it's just squared. But it says, what if we have something like f of x equals 3x minus 4 to the 15th? Do we want to multiply that out 15 times? Combine, combine, combine. It would be crazy long. It would be a very long polynomial. It'd start with something to the 15th power, then you'd have 14, 13, 12, all the way down. Think how long that polynomial would be. Do we want to do that? No. There must be an easier way, right? So the easier way is using something called the chain rule. Okay, so if I had something like what we started with, 3x minus 4 squared, here's the trick. We temporarily treat this like a variable, like a w substitution in Algebra 2, like w squared. How would I take the derivative of w squared? I would do 2w. So we do that. So we're like, okay, we're going to have 2 times this inside part, and it's to the first. However, if I go ahead and multiply that out now, I have 6x minus 8. Is that what the derivative was? No. Okay, I need 18x minus 24. How is it different? What's happening here? What do I need to multiply by to get the other one? 3. Where do we think the 3 comes from? It comes from the thing that's inside. You guys see 3x minus 4? What's the derivative of 3x minus 4? 3. This is the derivative of what's inside. Derivative of what's inside. Do you know what I mean by that? So what's inside the parentheses? So it was the derivative of the 3x minus 4. That's tacked on to the end. It creates a little chain. So we can do this many times. We can have like lots of parentheses, and we would keep tacking on chains on the end. Okay? And if you multiply this out, you will indeed get that y prime is equal to 18x minus 24, so it works. So if I had something like f of x equals 3x minus 4 to the 15th, its derivative would look like f prime of x equals 15 times 3x minus 4 to the 14th, and then times 3. Again, we don't want to multiply out 3x minus 4 to the 14th. We're not going to distribute that to write the final answer. My final answer I would probably just write as 45 3x minus 4 to the 14th. Oops, 14th, not 15th. Does that make sense? Okay. So what it's saying is that in order to do this, we use something called the chain rule. It's an easy concept, but it makes sense if you think about the w substitutions from Algebra 2. We just temporarily replace it. So we're like, oh, what if I had w squared? Its derivative would be 2w. And then we take the derivative of the inside. So it says, look for the inside part and set it equal to u. Therefore, in this problem, we'd have u is equal to 3x minus 4. Then we take the derivative of u to the 15th, which was our 15u to the 14th. But we also need to multiply by the derivative of u. I always say multiply by the derivative of what's inside. Okay. So it says y. So think about your unit conversions from chemistry. Do you guys remember when you would do things like miles per hour? Like if I had 2 miles per hour, and then I would put miles on the bottom, meters on top. Maybe there's 1,609 meters in 1 mile, right? And then the miles would cancel. And then I'd be like, well, what if I want meters per second? Well, then I'd put hours and minutes. There are 60 minutes in 1 hour, right? Do you guys remember doing this? And everything cancels out. So then you're like, oh, hours and hours cancel. Right now it's in meters per minute. This is the same concept with this. So here's what it looks like. So it looks like the derivative of y in terms of x is equal to the derivative of y in terms of u times the derivative of u in terms of x. Okay, we're not going to write out this notation every single time. You're just going to kind of understand the concept. So it says if f and g are differential in their domains, then the composite function y equals f of g of x. So g of x is the inside. Ends up being y prime equals the derivative with that inside still the same times the derivative of the inside. Okay, this is a note card one. It's always on the AP test in that form. So if it says if y is a function in terms of u, then I can take the derivative of f in terms of u. And u is a function in terms of x, then I can do the derivative of u in terms of x. This all gives me the derivative of my original function in terms of x. Okay. I know this is weird. I don't typically do the notation, so I'm just going to explain how to do this without the notation. I think you guys will feel pretty good about it. All right, yeah, Kyle?
For that like notation, how is that working? You use like f and u, and the next one you use like what was on the other side of the equal sign.
Yeah, so basically it's saying if you rewrite something like this, so don't write this, but you can look up here and pay attention. So I can write this as f of u is the square root of u. Does that make sense?
Yeah.
And then I can take the derivative just with u. So this would be 1/2 u to the negative 1/2, right? But we can say, well, as a second part of the problem, we know what u is. U is the inside part. It was 2x minus 4. Right? Well, what's the derivative of u in terms of x? So u prime. So maybe I should write it out with the du over dx. So let me write this one. Instead of f prime of u, I'm going to write df over du. It's always dangerous with the u's and f's. Gotta be careful. All right, so what is the derivative of u in terms of x for this u equals 2x minus 4? What's its derivative? 2. So then you put these together. So you're like, well, if I want the derivative of f with x values, I just take the derivative of f in terms of u, and I multiply by the derivative of u in terms of x. Do you see how the unit conversion thing works? The du's go away. So the derivative of f in terms of u is that 1/2 u to the negative 1/2, and the derivative of u in terms of x was 2. It's just like substitution, yeah. And then you replace that u with what it's equal to, and then you get everything in terms of x. Really complicated, isn't it? All right. We don't typically write things like that. We just kind of know the rules for chain rule. So when I do this problem, here's what I do. I identify what the inside is. Do we all see what the inside is? So it's kind of like a composite function, like f of g of x. So my inside is the 2x minus 4. And I think to myself, well, this is some kind of function, and it's raised to the 1/2. So I have kind of like a w to the 1/2. So if I was taking the derivative, I would have that 1/2 go to the front. I'd have my w, so that inside part, 2x minus 4 to the negative 1/2. But then I always multiply by the derivative of what's inside. Well, what's the derivative of what's inside? 2. That's it. So then this 1/2 and 2 actually cancel. So our answer is 1 over the square root of 2x minus 4. That's what that means, so 1 over the negative exponent. Could you leave it like this with a negative exponent? Sure. Doesn't matter. All right, so on number 2, this one doesn't have parentheses. Can you identify what the inside part is? Yeah, what's happening here? This is sine of x in parentheses squared. That's what that represents. So our inside is sine of x. So we think of this as w squared. Well, w squared, when I take the derivative, I'm going to have like 2w, right? So my y prime is going to be 2 times sine of x, and it's now to the first power. You don't have to write the first if you don't want to. But we need to tack on the chain. So what is the chain for this one? Cosine of x. It's the derivative of what was the inside part. Does that make sense? So we end up getting 2 sine of x cosine of x, which the AP test, one time I saw them write this as something else. I haven't seen them use this identity very often. Do you guys remember what 2 sine of x cosine of x is? It's sine of 2x. Do you guys remember that? They had that as an answer one time. And the students were like, am I supposed to know all my identities? No, you don't have to know all your identities. It's fine. But if you're taking Calc BC, you do have to know them. How fun. All right, so next one. So this is a little bit different. It doesn't mean the same thing. Do you see how it's sine of the inside part, x squared? So this isn't sine of x in parentheses squared like the last one. This represents something different. I don't have to put parentheses on this. I could have written sine of x squared, and you would have to know that there were invisible parentheses there. Do you guys all know that? Okay. Because otherwise we'd put the square like between the sine and the x, right? All right, so we have sine of a w. Well, if I have sine of w, its derivative is going to be cosine of w, right? So we're going to have cosine of the inside. So notice how the inside stays the same. I'm not writing 2x there. Just at the very end, I'm tacking on the derivative of the inside. So the derivative of the inside, 2x. So that's our answer. So you could write the 2x out front if you want to. It doesn't matter. If you just left it like this, I would count that as correct. All right, you guys try number 4. So write what you think the answer is. Yeah, Claire? Mm-hmm. Here's what we're doing today. All right, anybody feeling brave? Okay, so what do you think?
Is it 100 times x cubed minus 4x plus 2 to the 99, and then times 3x minus 4?
100 times x cubed minus 4x plus 2 to the 99. And then times 3x squared minus 4. Okay, now the way that I wrote it right now would be incorrect. So be careful. What do I need? Yeah, you have to put parentheses around that last part. Perfect. Does that make sense? All right, so the next one. You could do quotient rule. I wouldn't do quotient rule. I would first rewrite this so it's x squared plus 1 to a power. What power do I have? A negative, because it's on the bottom, and a 1/4 because it's the 4th root, right? So negative 1/4. That makes it a lot easier. So now when I do my low d high, or not low d high, what am I talking about? When I do my chain rule, I do negative 1/4 times x squared plus 1. I subtract 1 from the power. So negative 5/4 times the chain, which is 2x. Does that make sense? You get it? So the derivative of the inside, the x squared plus 1, gave us the 2x. All right? Yeah, Sean? The negative 1/4, because it's whenever you have a negative, like something on the bottom, like if I had 1 over x squared, that's really x the negative 2, right? And then if I have a 4th root of x, that's x the 1/4. Does that make sense? So it's a negative and it's a 1/4. A little tricky. All right, so all I would do on this one is I would just clean up the 1/4 and the 2. So 2/4 would be 1/2. So I would write it as like negative x and then x squared plus 1 to the negative 5/4. So the AP test might have it in that form. They might have it as a denominator. Like they might say like negative x over the 4th root of x squared plus 1 to the 5th, like something like that. Lots of ways we could write this. Okay? All right, so number 6. So I'd probably do the quotient rule on this one, or you can raise it up and do the power or the product rule with a negative exponent. Yeah.
Would it be negative 1/2 versus 1/4 times?
Oh, I forgot my 2. Thank you. So a 2 here. All right, thanks. I need to write down my points before I forget. So Angel got a point earlier, or right now. Someone else got a point. I don't remember. It was over there. Oh, it's Hallie. All right. So number 6. So this is what Maury always does, because Maury hates the quotient rule. I don't know why people hate the quotient rule so much. If you learn the little jingle, you're good to go, right? I guess people didn't learn this when they were in high school, but I learned it. All right, so here's what Maury does every single time. He writes it as a product. So x the 5th minus 1 to the negative 1/3. And then he does the product rule, which works. You can do that. Here's these. Some of these we're doing in class. This isn't due until the day of your test. All right, so we have first is 5x times the derivative of the second. So this is going to be this one and this one. So the derivative of that second piece uses the chain rule. So it's chain rule within the product rule. So you're going to do negative 1/3 x to the fifth minus 1 to the negative 4/3. Quotient rule is the product rule, yeah, with the chain rule. All right, times 5x to the fourth, and then plus the derivative of the first thing, so 5 times the second thing normal. So x to the fifth minus 1 to the negative 1/3. So clearly there's some cleaning up that you can do there. It looks a little nasty. I don't know. I don't mind too much. I think on one of these homeworks I say just write the first step. So you could leave it like this on your homework. Isn't that nice of me? But if you were going to combine, I would combine like your 5s, your x's. So you'd have like 25, well, negative 25 over 3x to the fifth. And then times that x to the fifth minus 1 to the negative 4/3. And then plus 5 times x to the fifth minus 1 to the negative 1/3. Like that would be combined. And then you could obviously like put those on the denominator, get common denominators. There's lots of ways that you can change your answer. So a good test taking tip, just in general, this is good for like the SAT or PSAT, which you take next week, right? Is if you get an answer and you're like, I don't know how to simplify it to whatever the test has, just plug in a couple numbers. Like I would just plug in 1. Well, you get 0. But if I plug in 1 here, do you see how I get 0? So any answer, A, B, C, D, or E, that doesn't have 0 as an answer would be gone, right? And then maybe plug in like 0 and see what you get. So you can do things like that to help you. All right. So this next one. So it looks kind of like a chain rule with a quotient rule inside of it, but again, make things the easiest that they can possibly be. Okay, so this is really like 1 over the square root of t squared minus 2. Like that 1 inside the root doesn't really, it's not really mattering too much to us, right? So I can write this as t squared minus 2 to a power. So what power? Yeah, negative 1/2. Does everybody get that? And then I take the derivative. So the derivative is going to be negative 1/2 t squared minus 2 to the negative 3 over 2, and then times the chain. So the derivative of the inside is just 2t. And you can simplify if you want. We'll just start leaving them. It's fine. All right, and then maybe sometimes you do want to do a quotient rule. Like I'd probably just do the quotient rule on this one, because it would be like a chain with a square root on the inside of it, which is going to be kind of gross. So I would just do quotient rule. So I'm going to first write it as negative 1 over x to the 1/2 plus 1. So there's lots of different ways you can do these. You don't have to do it this way. So let's do quotient rule. So the quotient rule says our low, x to the 1/2 plus 1, d high. So what's the derivative of the high? 0, yeah. Minus high is negative 1. D low is 1/2 x to the negative 1/2. And then all over the square of what's below. And you can simplify it if you want to, but if I'm letting you leave it as the first step, kind of nice. You can just leave it like that. That's fine. All right, so number 9. So find the equation of the tangent line at the given point. So we have f of x equals 3x cubed plus 4x raised to the 1/5 at 2, 2. So when I find the derivative, right, to find our slope, we do 1/5 times 3x cubed plus 4x to the negative 4/5 times the derivative of what's inside. So times 9x squared plus 4. When we do that, make sure you put the parentheses around the 9x squared plus 4. So on the AP test, you get points for steps. So I had a really bright student a few years ago. She started out on AP Calc as a freshman. She's super smart. And she would try to do everything in her head, which was great. She was brilliant. Like, she could do a lot of things in her head. But I was like, Christina, if you take your AP test and you just write the final answer, you're going to get 1 point out of 9 on every free response question. They go through and they give check marks for all of your steps. So this would probably apply to you, Jacob. You're looking at me like, well, that's crap. Jacob does a lot of things in his head because he can, but maybe you should write steps on these ones. So, so the next one. So I have f prime of, so I want to find my slope. So I'm going to plug in the x value I have, which is 2. So let's see. I get 1/5. I can probably use a calculator to help me on this. It's a little gross. So 3 times 8, so 24 plus 8 to the negative 4/5 times 36 plus 4 is 40. Jacob, do you want to prove that you can do all this in your head? I know he can. All right, so 32 to the negative 4/5. Yeah, so let's think about it. The 5th root of 32 is 2, right? So if I just did the 5th root, I'd get 2. So what's happening is I have 1 over the 5th root of 32 and then raise the 4th. So don't forget your 4th power there, Angel. So we have, oh, I see, you're already there, good. So we get 1 over 16 because we had 2 to the 4th, which is 16, right? So we're going to do 1/5 times 1 over 16 times 40, which does work out to be 1/2. So you can reduce things out, like 5 and 40 make 8. 8 and 16 make 1/2. So that's our slope. So we have y minus y1 equals m times x minus x1. Good? All right. All right, try the next one. So find the derivative of the tangent line there. I need to go back there. Oops. Did you guys get 5 over 4 for the slope? That was a lot of computation there. 10 over 8, 5 over 4. 3 over 4?
The 8 would be the 4.
What did I do?
Second one, right? 2.
Oh, yeah, gotcha. Thank you. So this is 6. No, hang on. We're 2 we're plugging in, right? So 4 plus 2. So 6. So then this is 6. And this is 6 and... Okay, so 3 over 4. Thank you. All right, so we get m equals 3 over 4. And then we have our 2 comma 4, so I'm going to do y minus y1 equals m, which is 3/4 times x minus x1. So we get that as our equation of our tangent line. Man, you guys just have quite the tally going on. All right, so number 2. So given that f of 2 equals negative 3, f prime of 2 equals 6, g of 2 equals 3, g prime of 2 equals negative 2, and f prime of 3 equals 4, find the derivatives of the following at x equals 2. Okay, these are classic like table problems, so I don't have this information in a table. But you guys had a homework the other day that had a bunch of table problems on it. And I would say half of you guys got that concept, half of you did not. I graded the front page, and I was like, I think I'm just going to let this be. And I gave you the grade based on the front page, and I didn't grade the back page. So we're going to practice that again today with the chain rule. So for A, we have y prime equals. So what I tell students typically is when you have something that looks like this, like f of x cubed, if you think about your function being sine of x, it clears things up in our head. So if I had like sine of x and I cubed it, you all know how to take the derivative of that. You just did it today. So what would the derivative of sine of x cubed be? 3 sine of x squared times cosine of x. So what does that mean? So if I have a function and I cube it, its derivative is 3, the function squared times what? F prime of x. Does that make sense? So if you think about some other function and plug in that other function, it really helps. Sine of x is always a good one to think about. So in this case, our derivative, y prime, is going to be 3 times our function f of x is now squared times the derivative of the inside, f prime of x. Now we're finding the derivative at 2. So we're going to plug in 2. So I'm going to find y prime of 2 is going to be 3 times whatever f of 2 is squared times f prime of 2. So show that step. A lot of you guys on your homework didn't show that step, and then you got the wrong answer, and I was like, I can't help you. I don't know what you did. So show the step where you have f of 2, f prime of 2. So f of 2 is going to be negative 3. So we have 3 times negative 3 squared times f prime of 2 is 6. I should know this in my head, but that's fine. So I get 3 times 9 times 6. So I get 162. That's our answer. Does that make sense? All right, so let's think about the next one. So f of g of x. This is the definition of the chain rule, right? That's the thing I put a little red star next to, and I was like, this is a flashcard thing. We need to know this. So don't look back. Just think about what's happening. So what if you had like cosine of sine of x? That's what it's saying. A function inside of another function. How would we take the derivative? Not product rule, because it's cosine of that. It's not cosine times sine. It's the chain rule. So what would we do? We would do sine of inside sine of x times the derivative of the inside, cosine of x. So what we're going to do here is we're going to do y prime equals f prime of the inside stays the same, right? And that always happens with the chain rule. The inside's the same for the first step, but then we do times the derivative of the inside. You need to know how to write that just like that. You need to know that. It's all over the test. It's a pretty important rule. I told you we use it every single day for the rest of the year, right? So we don't always write it like that, but we use that every day. All right, so if I want y prime of 2, I'm going to do f prime of whatever g of 2 is, and then I'm going to multiply by g prime of 2. So I'm going to have f prime of g of 2 is 3 times g prime of 2 is negative 2. So f prime of 3 is 4 times negative 2, so we get negative 8. Does that make sense? All right, usually when you have these table problems, notice how these are all like f of 2, f prime of 2, g of 2, g prime of 2, and then all of a sudden it says like f prime of 3. You guys should be thinking, well, how am I getting this f prime of 3? It's from plugging another function into it's a composite function, composition of functions. Does that make sense? Okay. Okay there? All right, so go ahead and try the next one. So this one is just the what rule? Product rule. All those right. So 6 plus 18. Did you guys get 24? Yeah, are you guys almost there? Yeah? Back table, you guys good? Okay, good. And then we have quotient rule in the next one. So quotient rule, so we do our low g of x, d high is f prime of x. minus high is f of x, d low is g prime of x, all over the square of what's below, so g of x squared. So if I do y prime of 2, I'm going to find g of 2, which I believe is 3, and then f prime of 2, which is 6, minus f of 2, which is negative 3, g prime of 2 is negative 2, all over g of 2, which was 3 squared. So I get 18 minus 6 over 9. Is that right? So 12 over 9, which reduces by 3. So 4 over 3. So 4 over 3 is the answer. Do we feel better with those now? Okay. All right, and then the very last thing, so sometimes we have multiple chains. So I told you it's called the chain rule for a reason, because sometimes we do times the chain, times the chain, times the chain, times the chain. Okay, these are tough for students, especially the first day that you're learning this. So we're going to work on these. So if you don't get it right now, you will get it, I promise. Okay, so what we're going to do is we're going to start. So it's cosine of tangent of x, okay? We're going to start with this being our, like, w. So if I had sine of w, what is the derivative of sine of w? Cosine of w. So we need that whole inside part to be the same on the first step. So it's going to look like f prime of x equals sine of this whole inside part, which was w. So we're going to do cosine, or not, dang it, why did I do sine? Hang on, starting over. So if I have sine of w, its derivative is cosine of w, right? So I'm going to do cosine of, and the whole w part is the same. So what was the w part?
Cosine.
Cosine of tangent of x. Okay. So this part was w. Now we multiply by the derivative of w. So now we're looking just at the w. Well, what's the derivative of cosine of tangent of x? So now it's using a second w substitution. It's like cosine of u, right? So what's it going to be? Negative sine of the inside tangent of x times secant squared, the derivative of tangent. Do you guys see that? So this is like u, and this is the derivative of u. So it's one step at a time. Okay, you don't have to simplify it, just leave it like that. All right, do we see how the next one is what I call a double chain? Because it's y equals the sine of the inside, 2x cubed minus 1. All of that is being squared. So right now it's like w squared. Okay, it's something is being squared. That's like our outer function. Something is squared. So if I'm taking the derivative of w squared, I get 2 times w, right? So I'm going to start it out with 2. And my w was the sine of 2x cubed minus 1. So that's our 2w. But now I need to do the derivative of w. So what's the derivative of sine of 2x cubed minus 1? Cosine of 2x cubed minus 1. Don't you guys wish you could just scoot everything over like I can? So exciting. I ran out of room, so I'm giving myself more room. So I have cosine of 2x cubed minus 1 times 6x squared, exactly. I don't know if I could fit that in there. Let me try to fit it in there. Times 6x squared. Okay, and that's called a double chain. Okay, so we can have double chains, triple chains, and so on. Chain rule can keep going. It's annoying. All right, feeling somewhat okay with this? All right, so let's try